Hello, so I'm going to explain MEXT Physics Undergraduate 2015 Question 3. Number 1. An object of mass m is hanging by a light spring of force constant k from the ceiling, as shown in Figure 3. A small ball of m which moves vertically upward collides with the object. After the collision, the object and the small ball stick together and oscillate in simple harmonic motion. Before the collision, the object is at rest. The speed of the small ball just before the collision is denoted as v. The acceleration of gravity is denoted as g. Answer the following questions. 1. Find the amount of stretch of the spring from its natural length before the collision. So what you have to know to solve this problem is that when a spring is stretched by a distance of x, it wants to go back to its natural position. So that force is the spring constant k times the distance. And we can just solve it by the m is the force that is going down. So there is a gravitational force of m that is mg, and it's equal to the force that the spring want to go back to the natural position, that is kx. So we can write mg is equal to kx, and to write it in equal to x, it's mg over k. Number 2. Find the speed of the object and the small ball just after the small ball collides with the object and they stick together. So the theory that you have to know is that the momentum is conserved. So the momentum before is equal to the momentum after. So let's say there is a small m here and it moves towards this big M. So the momentum here, since the big M doesn't move at all, we only have the momentum of the small m and the velocity v. So the momentum before is mv, and after it collides, the m and big M sticks together and move towards the upward direction. And let's say that this velocity is u. The velocity after the collision is u. So we can write mv is equal to the sum of the mass, that is big M plus small m, times u. And to write it in terms of u, to write it in equal to u, we can write m over m plus big M times v, and the answer is C. Number 3. Find the amount of decrease of the sum of kinetic energies of the small ball and the object before and after the small ball collides with the object. So the theory that you have to know is the kinetic energy is equal to a half times mv squared. And since we are asked to find the amount of decrease before and after, so we need to find the kinetic energy before. And the kinetic energy before is just the kinetic energy of the ball before it collides with the big M. So that kinetic energy is a half times the mass times v squared. So the initial kinetic energy is half times mv squared. And after a small ball collides with the object, it has the sum of the mass of this both object, that is big M plus small m, and the velocity is the velocity of which it is after the small m collides with big M, that is u. So we can write the kinetic energy after is a half times m plus small m times u squared. And we know from the problem before is that U is equal to m over m plus big M times V, and substituting that we get a half times m squared over m plus m times V squared. So since we are asked to find the decrease, uh, we write k before minus k after. So it is equal to a half times mv squared minus a half times m squared over m plus m times v squared, and we factor out the a half times mv squared. This became 1, and this became m over m plus m, and we multiply both. We multiply 1 so that it has the common denominator of m plus m. So we multiply 1 by m plus m, and we will be left with m big M, and the bottom is m plus m. So the answer is big M times small m over 2 m plus m is equal to p times v squared. So the answer is D. Number 4. Find the period of the simple harmonic oscillation after the small ball and the object stick together. So the theory that you have to know that is F, the force, is equal to mass times acceleration, and in simple harmonic oscillation we can write A as the distance r times the angular velocity, that is omega squared, and we can write omega as 2 pi over t. So since F is equal to ma, and we can write F as kx, and the ma and the mass is the sum of both of these mass, that is big M plus m. And since this is a simple harmonic oscillation, we can write A as x omega squared. We can cancel x, so we are left with k m plus m and omega squared, and we can move m plus m to the bottom of k, and we can square root both sides, so we get k over m plus m square root is equal to 2 pi over t, and we can move t here and k over m plus m to the right side, so it became inverted, so t is equal to 2 pi square root m plus m over k. So there is a memorizing, so you can just memorize this form, but when you forget, just remember this process. So number 5. During the simple harmonic oscillation, a small ball and the object, which are stuck together, the spring is at its natural length when the object is at its highest position. Find the kinetic energy of the small ball just before it collides with the object. So the theory that you have to know is that the potential energy of spring is a half times k times x squared, and the U gravity, the potential energy of gravity, is mgh. And you should know that the mechanical energy, that is the potential energy plus the kinetic energy, is always conserved. So before or when the moment the small m and big M collides and move to the velocity with the velocity u, there is the kinetic energy, that is this, and the potential energy of the spring, that is a half times kx squared. And after it reaches the highest position, there is no potential energy of a half times kx squared anymore, since it is at its natural length. And the energy that we have here at its highest position is the potential energy of m plus m gx. So we can write it like this. So this is a long process. So we can write u as m over m plus m phi, and we get this. And we can write x as mgk, and we get this. So we can write x here too as mgk, mg over k. So we move this to the right side, so it became minus. And let's factor. We have to factor something, or before that, we multiply. To make our life easier, we multiply all of this by 2 to get rid of this 1 over 2. So this became 1, this became 1, and this became 2. So that's why it became 2 here. And we can factor out mg squared and k, mg squared and k. So we can factor out mg squared and k. So we are left in this side is 2 m plus m. So we write 2 m plus m. And since we factor out mg squared over k, we are left with m. So it is 2 m plus m minus m. So we can multiply big M plus small m by 2, and we get 2 big M plus 2 small m minus big M. And 2m minus big M, 2 big M minus big M is m, plus 2 small m. And since we are asked to find the kinetic energy of small ball is a half times mp squared. And to get that form, we move m plus m here to the right side, so it became like this. And we move m here to the bottom side, that is here. And to make mv squared to be a half mv squared, we multiply both sides by 1 over 2. So the answer becomes m times m plus m times m plus 2m plus g times g squared over 2km. That is the answer F.